For today's topic, we'll be talking about what the body needs in terms of basic necessity for overall health. We'll talk about the number of calories you might need to consume and also other nutrients that don't actually provide energy but are still critical for a healthy body. So here you can see listed some of these essential nutrients. We've got a few that are present in relatively small amounts. We'll talk about these vitamins and minerals that we don't need to get a lot of. And then other ones, carbohydrates, proteins, fats, and water that we need in large quantities. We'll also be talking later on about calories and how many calories are present in each of these different types of food items. You can see here that protein has 4 calories per gram. That's the same with carbohydrates, 4 calories per gram. But fats have over twice as much, 9 calories per gram. And that's why if you eat a high-fat diet, it's a lot easier to gain weight because there's over twice as many calories in the same amount of food. So as mentioned, some of the foods that we take in, we are using as sources of energy. And we measure energy in calories, which we'll talk more about later. But other nutrients we take in are essential for our body, but are not sources of energy. Things like water, vitamins, minerals, all of those are 0 calories, no energy at all. And yet you still need them to be healthy. So we'll kind of talk about the roles of especially vitamins and minerals in the body. We'll also be talking later on, more in a future topic, about fiber over here. Fiber is a type of carbohydrate that our body is not able to digest, but that still plays a variety of important roles in our health. So as I briefly mentioned, some of these items we only need in small quantities. So we call those micronutrients, right? Micro means small, like a microscope, looking at microscopic things. So vitamins and minerals we need in very small amounts. On the other hand, the opposite of micro is macro. If you ever use sort of an old-fashioned camera, not your smartphone cameras, you may have heard of micro or macro setting, where macro is like the big setting. And so for macronutrients, these we need in larger amounts compared to the micronutrients. Water, carbohydrates, proteins, and lipids. Lipids is a broad category that includes fats, but other things like cholesterol, phospholipids, and many more. Before we can get into what we need, let's talk about what happens to food once it gets inside our body. Previously, we've learned about the digestive system, but now we're talking about once it actually gets inside the cell, what happens to these molecules? So this first process up here, where a larger molecule is being broken down into smaller molecules, is called catabolism, or a catabolic reaction. One way to remember this is think C for cut. You are cutting a larger molecule into smaller pieces, breaking it down. And the reason for this is to release energy that can then be used to do work. We're talking, of course, about making ATP. But additionally, you'll see down here there's some heat energy that's lost, which is not able to be used by living things for doing work. So C, catabolism, cutting large molecules into smaller pieces. The opposite of that is anabolism, or an anabolic reaction. That's where you're taking smaller molecules, using energy, and you're doing that to put them back together to make larger molecules. Oftentimes, when we think about metabolism, a lot of us only think about the breaking down, but metabolism also incorporates the building up of substances. So metabolism is this overall category of reactions in our body that are breaking down food and also combining those individual molecules to make larger ones, like proteins or fat or bone, etc. Here are some common terms we're going to be encountering in this topic and also going forward: monomer and polymer. This prefix here, mono means one, like a monorail. It's a railroad system that has only one rail. And poly means many. Or monogamy, married to one person, versus polygamy, married to many. So a monomer is one small molecule, an individual one. A polymer consists of many monomers. You can see here we have a number of monomers that are linked together to make this polymer, right? So we've got 1, 2, 3, 4 monomers in this polymer. And the buildup and breakdown of these goes back and forth. This is going on constantly in our body when we eat things and digest them, and then use that to synthesize new products. In addition to polymer, you'll also hear the word macromolecule. I'm going to use those interchangeably. So if you hear macromolecule or polymer, we'll consider those the same thing, larger molecules made up of smaller ones. Here's a question to consider. You've got a friend who's raving about this new 0-calorie energy drink. And you're in biology class, and so you're wondering, can a 0-calorie drink actually contain energy? What do you think? Well, the answer is no. Not in the way that we use the term energy in science. It can make you feel energized, but it doesn't actually contain energy if it's 0 calories. There's a difference between that. So when we're talking about energy in science, we're talking specifically about nutritional energy, contains calories, can be used to do work. And here you can see different food items that contain usable energy, including protein, 4 calories per gram, I've mentioned this before. Carbohydrates, also 4 calories per gram. And fat, twice as much, plus a little bit more, 9 calories per gram. So calories are a way to measure the amount of energy stored in food that can then be accessed after we digest that food. You will not need to know this next number, but just for reference, for those of us who are of age, if you choose to consume alcohol, alcohol is kind of in the middle at 7 calories per gram. And that's why if you drink, say, 3 beers or so in an evening, you actually can consume a large number of calories, somewhere in the neighborhood of 600-700 calories, equal to a meal just from liquid. So you'll want to know these numbers for protein, carbs, and fat because you'll be asked to do some calculations later on related to the number of calories in these items. So in all, regardless of where the calories come from, how many calories do we actually need to take in each day? Well, there are a couple of components to determine this. One is something called your basal metabolic rate, or BMR for short. Your BMR is measuring how much energy are you actually using doing nothing. So when you're at rest, not asleep, but you're just laying down, not moving, how much energy is your body still burning to maintain the body as it is, to keep all the processes going, everything alive, replace dead cells, how much is being spent. So a lot of this depends on your height, your weight, your age, your sex, but on average, a female's BMR is 1,400 calories per day, whereas a male's on average is 1,700 calories per day. Any thoughts as to why there might be a difference between females and males in terms of their basic number of calories to keep their body going, doing nothing? What's different about males that require them to have more? Well, one thing is that, on average, males are larger. Taller, bigger, larger body mass. If you have a larger body, you actually need more calories to maintain that larger body. And a second thing is that, again, on average, males have more muscle than females. And it takes more energy to maintain that muscle than it does fat. So there's a couple of reasons why the basal metabolic rate for males is higher on average than females. But none of us are just sitting doing nothing. Even if you're watching this video, you're at least doing something. You could be laying in bed watching it, but you're doing something. And hopefully you're taking notes. Always remember to do that. But you're using more than your BMR. So the total energy you use per day, we call your total daily energy expenditure. That number includes your BMR plus the energy spent for all the other activities you're doing during the day. And that can be highly variable. If you are kind of a sedentary lifestyle where you go to class, you go home, you watch Netflix for hours, and you go to bed, then your energy you're using for the day is not going to be, that much higher than your BMR. But if instead you play sports, you like to go running, you have a job you do that requires a lot of exertion in terms of physical activity, that could then be potentially, twice as high as what your BMR is. And sometimes even more than that if you're really a professional athlete, for example. The last thing for this topic we'll introduce here, and then in class we'll go through an activity with this, is a nutrition facts label, looking at how we can help gauge how many calories are present in the food we're eating. Before I get into how to navigate this label, one thing I wanted to point out here is what's called the serving size up at the top. And the serving size, common misconception here. The serving size is not how much you should eat. It's not a recommended amount. The serving size is the average amount that a typical person eats in a single sitting, excuse me. So how much somebody usually eats, that's what the serving size is. And the serving sizes have actually gotten larger over time as packaging's gotten larger, and we found, for example, that if you give someone a 14-ounce soda and a 20-ounce soda, usually people are going to finish them regardless of the size. So even though they're different size products, the serving size might be the same, the entire bottle. So the serving size is how much somebody eats normally of that item. And then everything below that, serving size, how many of those servings there are in the container. So 1 cup's the serving size. There are 2 of those in the container, so the container has 2 cups. Everything below that is the amount per 1 serving, in this case per cup. 250 calories per serving. Of those 250 calories, 110 of them are coming from fat. Over here tells us the actual amount in terms of mass in grams or in milligrams. And you'll see this percent daily value. Oftentimes percent daily value is abbreviated as percent DV. Percent daily value is looking at how much of this nutrient should you get. So here you'll see all these things in I don't know, this orangish yellow color, I guess, is just to limit these nutrients right here. So these are the generally not healthy things. We'll talk more about that and how actually not all fats are bad. But for those items, the percent daily value is actually a limit, where 100% is the limit for those bad things. What that means is you get 20% of your sodium here in one serving. And for sodium, you don't want to go above 100% daily value. That's your maximum allowed amount for the day. So that means you could have 5 servings of this, or 5 cups, because 5 times 20 would get us to that 100% limit. Now down here in the blue-green color, those are the good things. For those items down here, we've got fiber, also got vitamins and minerals. For those things, 100% is the minimum goal. You want to get at least 100%. More is even better. So that's for the good items. That means to get your calcium requirements for the day, you would want at least 5 servings of this, assuming you're eating nothing else. That would get you then to 100%. But the problem is that would max out your sodium. So ideally, you could get calcium in other ways that has less sodium than that. And we'll do an activity with this in class.